Okay, so we are going to find some intercepts and asymptotes and sketch the graph of this rational function. As you probably know by now, or you should know, let's hope, the first step to do here is to factor, because only when you factor can you tell what factors the top and the bottom have in common and which ones they do not have in common. That allows you to see where there's going to be a vertical asymptote versus where there's going to be a hole. So let's get started. We can say that this is going to be equal to, first of all, there's a GCF on the top. So that can get pulled out to get 2 times x squared plus x minus 2. And on the bottom, this can also factor to get x times x plus 1. The top, let's hope, can be factored further. X and x. And plus 2 minus 1 fit here. On the bottom, x times x plus 1. Okay, I'm going to need lots of space on the right-hand side, so I'm going to copy that over here. The factorization is 2 times x plus 2 times x minus 1 over x times x plus 1. Remember that if I want to find the intercepts, or the asymptotes rather, the first thing I need to do is look for the zeros that the bottom has, and then inspect those to see if they're shared by the top. So the vertical asymptotes, which will be determined by the zeros of the bottom, are possibly at x equals 0 and -1. The reason I say possibly is that if one of those is a shared 0 with the top, then it's not a vertical asymptote, but a hole. But you can see that the zeros of the top are x equals -2 and +1. +1, not -1. So the zeros on the top do have a significance even in this problem though, because they're going to be the x-intercepts. When the top is 0, as long as the bottom is not, that means that the function is equal to 0. So we've found, well, I'll say not just intercepts in general, but we found x-intercepts. That's x equals -2 and +1. What about the y-intercept? The y-intercept is when x is 0. Now, hang on, we already said that this has a vertical asymptote at x equals 0. So this actually does not hit the y-axis. It has a line at the y-axis where it gets close to it but does not touch it. So there is no y-intercept. Just one more thing here, and that's that we need to get the horizontal asymptote. Sometimes a function has one, sometimes not. The thing that determines whether it has a horizontal asymptote is the comparison between the degree of the top and bottom. The degree of the top is 2. The degree of the bottom is also 2. If the degree of the top is larger than the degree of the bottom, there will be no horizontal asymptote. If the degree of the top is equal to or less than the degree of the bottom, then there will be a horizontal asymptote. This is equal, and so the horizontal asymptote is the lead coefficient of the top divided by the lead coefficient of the bottom. So with that in mind, I'll go grab the lead coefficients. That's 2 on the top, 1 on the bottom. The horizontal asymptote is 2 over 1, which of course is our good friend y equals 2. All right, I am ready to draw a graph here with one little caveat that I'll run into in a minute. I've got vertical asymptotes at 0, usually shown with a dashed line, and also at -1, which I'll show with another dashed line. Okay, the zeros are going to be at -2 and at 1. And now I need to say, I need to cause this function to behave the right sort of way around the asymptotes. When I say behave the right way, what I mean is, like, when it goes toward this asymptote, does it do it like that? Or does it do it like that? On the left-hand side, it's fairly easy to see that because of the horizontal asymptote, which is at y equals 2, the function is probably going to do this as it goes toward the vertical asymptote. But we can do a little bit better than that. We can do a little bit better than just saying probably. Think of what the graph of the top versus the graph of the bottom will look like. So the top is going to look like this, 2 times x plus 2 times x minus 1. That means it will have, and sorry for so many colors here, it will have a 0 at -2 and at +1, and it's going to be a parabola. So it will do something like this, right? Parabola, not inverted, and it has those two as its zeros. The bottom is x times x plus 1. That will have its zeros at -1 and 0. So -1, 0. And this also is not inverted. So it's going to look like that. The reason I want to ask questions like this is that it tells us how the function behaves around the asymptotes. Let's take this one, that asymptote right there. Look at the left-hand behavior. Here's where these helper graphs come in so handy, because on this left-hand side of that asymptote, you are dividing on the top a negative number, that's negative, by a positive number. What kind of answer do you get when you divide negative by positive? You get a negative answer. So on the left-hand side of that asymptote, the function is negative, and that means that it goes down toward the asymptote. So it'll look like that. Ooh, I'll make it go through the intercept. There, it's going to look like that. Now look on the other side. Because we have the helper graphs, it makes it that much easier to see what's going to happen. On the other side, you are dividing a negative number on the top by now a negative number on the bottom. Well, negative divided by negative is positive. So on the other side of this asymptote, it is not going to do this. Nope, not that at all. It's going to go up. And here you need to be really careful because there is another vertical asymptote right there. So there's kind of a lot to keep track of here. But you go up on the right-hand side of that vertical asymptote. Now look at what happens as you approach the next vertical asymptote. You've got a negative number divided by a negative number. This also is positive. So this downward bell will continue up. And now we have the behavior between the asymptotes. Now look on the right-hand side. On the right-hand side, you have this and this. You have a negative number down here divided by a positive number up there. That has a negative answer. So what's going to happen on the other side of this asymptote at x equals 0 is negative behavior. It's going to be coming from down here. And coming from down there, making sure you hit this intercept right there, and then going up to the horizontal asymptote. So I'm going to get rid of the helper graphs now because they were only there while we needed them. And here in blue, with the asymptotes shown as red dashed lines, you have the actual function. I know it seems like a lot of work to go through to draw the helper graphs, but trust me, it does make it so much easier. And it also means you're not just blindly applying rules, you're actually doing things that make sense. And that makes all the difference.